Okay, so another example, okay? I'm sorry if it's boring, but I think it's worth doing. The S equals to 1. So first is, what is the dimension of this representation?
Three.
3. Good.
Sir, I had a question about the dimension. So, a 2 into 2 matrix has a dimension of 4, right? So,
Dimension is a word that is used that has different meaning in different contexts, okay?
oh, okay.
So a 2 by 2 matrix, it acts on a vector space whose dimension is 2.
Oh, yes.
Now, depending on what kind of matrix you're using, the matrices themselves form a vector space. So the dimension of the vector space of the matrices form is a different dimension than the dimension of the vector space the matrices act on.
Mm.
Okay, so let's do a little discussion about this on the side. So, so let's look at 2 by 2 Hermitian matrices, okay? So the most general 2 by 2 Hermitian matrix, let's call it A, can be written in the following form. A times 1 plus sum over bi times sigma I. Okay, so where sigmas are Pauli matrices. If I take A dagger, then so A and bi, these are real numbers, okay? So if I do this, then 1 is of course obviously a Hermitian matrix, but the Pauli matrices are also Hermitian, and therefore these are Hermitian matrices. So I'll leave it to you to prove that Hermitian matrices can be written in this form. So the dimension of the space. Before I go there, now Hermitian matrices form a vector space over a field. What do you think the field should be? Should it be
Complex numbers.
So okay, now he says it should be a complex number. So if I take a Hermitian matrix, say A1, and multiply it by a complex number A1, so A is a Hermitian matrix, and add another Hermitian matrix to it, multiplied by a complex number A2, small a2. So if this is a vector space, this should also be Hermitian. Is it Hermitian?
No, because
No.
Why is it not Hermitian?
if we use dagger on both sides, then the complex C would become minus I. So
Yeah, so A will become A1 will become A star, A2 will become A star, right? A dagger will become A1 star, but A1 is Hermitian, so that will change. A2 will become A2 star, and this will become A2. So this is not equal to A. Therefore, Hermitian matrices will not form a vector space that is a closed set over the field C. What should the field be then?
real.
Exactly. So this is a vector space. And the dimension of, so let's call this H. So the dimension of H is going to be 4. Where the bases are essentially what are the bases? The basis is just 1 and sigma 1, sigma 2, and sigma 3. These are the basis vectors. Now, is this a Hilbert space? We don't know, because we don't know if there is a positive definite norm on this space, right? And we are not interested in this course. A spoiler alert, it is a Hilbert space. You can actually introduce a positive definite norm, but I don't want to go into that. But this Hilbert space, this space, vector space, is very different from the two-dimensional vector space C2 on which these Hermitian matrices act in quantum mechanics, right? So Nahi, does that make it clear what I mean when there are different vector spaces you can construct?
Yes, sir.